Hey guys, this is Fraser from Things About Tutoring. Today we're going to be looking at this paper 1 question. So it's a non-calculator, otherwise it'll be very easy. And it's 5 marks. It's a pretty straightforward question in terms of what they're asking, but the actual solving it is a bit, you need to have a good understanding of the log laws and all of those. So basically it's asking us to take these logarithms and solve them for x. So how are we going to do that? Well, the first thing I want when I'm looking at a logarithm equation is I want everything to have the same base. Because if everything has the same base, then we can apply the other 3 log laws. Or 3, we can apply the other log laws. So from logarithms, we have change of base formula, and we have the other ones, which is like when you add logarithms, you multiply them, when you subtract, you divide, those ones. Now, I notice here that I have a 3 in the base, and I have a 2. So the obvious indication would be to change this into a base 3 logarithm. You could do these into 2, but it's just more work because you have to change 2. So first things first, I'm going to take this logarithm 2, and the reason I'm doing 1 over is because it's messy. I'd rather just use the formula for this, and then do 1 over the final product. So 2 log 2, 3. Well, first of all, I can just bring the 2 out, because it doesn't, the 2 is a constant. And then what I'm going to do is, I want to base log 3, right? So I'm going to have log 3 of something divided by log 3 of something. Now there's something on the top. Well, the way I remember it's in the formula book, but the way I remember it is that this 3 is a bit higher than the 2. That means that the 3 is going to go on top, and the 2 is going to go on the bottom because it's a bit lower. What's log 3 of 3? Well, what do we raise 3 by in order to get 3? We just raise it to 1 because that's the same number, right? So log 3 of 3 is actually just 1. So this becomes 2 divided by log 3, 2. Now remember, I said all the way at the beginning, it's 1 over this, right? So that means 1 over this is 1 over this, but 1 over something is the same as multiplying by its reciprocal. So that's just 1 times log 3, 2 divided by 2. So the answer, well, the intermediary step is done, and the answer is log 3, 2 divided by 2. And because we don't like having coefficients on the outside, we can only use some of the log laws when we have, we don't have, for example, I can't do something like 3 log 3, 7 plus 5 log 3, 2. This is not like 15 log 3, what is that, 14, right? We can't do that. We have to put these powers in, so then it's log 3, 7 cubed plus log 2 to the 5, and then we can do it. So with that means that this logarithm is 1/2 times log 3, 2. Now one of the log laws is if there's a constant on the outside, we can just bring it in and put it to this number in the middle as a power. So this number here, the 2, is a power. So that's log 3, 2 to the 1/2, and anything raised to the power 1/2 is just square root. So the final answer will be this, the square root. So, a little bit of working, but I just wanted to be clear. Now let's plug it back in. Log 3 root x equals, we just said this is log 3 root 2 plus log 3 4x cubed. Right? Now, another log law is when we're adding logarithms like this, we can combine them with the same, but they have to have the same base. Same base, we can combine them and multiply whatever is inside. So this becomes 4 root 2x cubed, and this is equal to log 3 root x. Now we have 2 logarithms being equal with the same base. Now that means that whatever is inside must be the same, otherwise we would have a different number on different sides, right? So that's a general pattern, that if you have 2 logarithms equal to each other, then then it means whatever is on the inside must be equal. So that means that root x equals 4 root 2 x cubed. Now you might say, oh, we can't divide by x because it can't be equal to 0. But actually all the way back at the beginning, we had that x is strictly greater than 0. So we actually can divide by it, but we don't actually have to. If we just move this root x onto the right with 0 equals 4 root 2 x cubed minus root x. So that means that root x and then 4 root 2 x to the 5 over 2 minus 1, so equals 0. And the reason I'm doing this is because maybe you could not be able to divide by x in some future case. And this is what you would do. You would move it over and then factorize instead of dividing. So then you would think, oh, root x being equal to 0 is a solution. But we know that this can't be the case. Actually, let's do that in red to make it extra obvious. We can't have that because we said we define the question as x is strictly greater than 0, and the reason we did this is because log 3 of 0 isn't defined, so we can't have that. Log 3 of 0 on this side is also not defined. So that means that the inside must be equal to 0. So this is equal to 0. That means that for root 2x to the 5 over 2 is equal to, the reason it's 5 over 2 is because I did root x cubed divided by x to the 1/2. You just subtract the powers. Equals 1. So x to the 5 over 2 is equal to 1 over 4 root 2. We square both sides. So when we square it, the 2, if I square this, I square this, the 2 on the outside and the 2 on the inside cancel. So that's x to the 5 equals. This is 1 over 4 squared is 16. Root 2 squared is 2. It means that x to the 5 equals 1 over 32. If you know your powers of x, if you know your powers of 2, you know that 2 to the 5 is 1 over 32, which means that 2 to the 5 is 32. That means that x is equal to 1/2. You might be tempted to do plus minus, but if it's minus 1/2 to the 5th, it's going to be minus 1 over 32, so it's only positive. So hopefully that was clear. This was actually a pretty difficult question. You sort of had to use all of the rules. You had to know the steps, the order in which to do them. Let me know if there were any parts that were unclear. But yeah, this is like a classic paper 1 question. It's very straightforward what you have to do. Obviously the maths is difficult. That's the whole point of HLAA, but this could easily be an SL question as well. But yeah, hopefully this is helpful. If you guys feel like you need a bit more tutoring, something maybe a bit more in depth, you want to do more of this kind of practice, feel free to head over to Think Smart Tutoring. You can sign up there super easily. You can have a trial lesson. We have online lessons. If you're in Amsterdam, we can do, if you're in the neighborhood of Amsterdam, we can do real life lessons. But check out the website. The link is in the description. Yeah, it's super flexible. And it's going to be really helpful if you guys need just that extra push to get the grade you need for university. So yeah, hopefully you have a nice day. I'll be making more of these videos, and I'll see you guys soon.